most likely this is a fibroblast cell. To me, it looked like a fibroblast. It's a connective tissue. Here we go, anaphase. You saw that? You saw how they separated? No? Ariel, you missed it? You saw. And then now it's cytokinesis. And voila. Okay. The mitotic spindles, a closer look. The mitotic, she mentioned on the video, is that right? The mitotic spindle, microtubules that controls chromosomes movement during mitosis. Centrostomes, the microtubules organizing center, and aster is a set of microtubules, which is, I'll show you a picture in a minute, that allows the chromosome to separate. And the spindle includes the centrosomes, the spindle microtubules, and the asters. The spindle that I talked about, mitotic spindles, include the centrostomes. You saw those protein molecules, the spindle, those fibers, spindle microtubules, and the aster, which I'll show you a picture. Kinetochore is the protein molecules that attach to the chromosomes and pull them apart. That's what the kinetochore are. So let's see a picture, says a million words. I don't know, you guys, right here. Okay, let's go over it. Let's go over it. In animal cells, assembly of spindle microtubules begins in the centrosome, right here, the centrosome, right here, the microtubules organizing center. So what is the definition of a centrosome? Is a microtubules organizing center. That would be centrosome. An aster, I said I will give you the definition later on. An aster is a radial array of short microtubules extends from each centrosome. So these are little microtubules, those little microtubules that is extending from centrosome. These are called aster, right here. Those are called aster by definition. And then kinetochore, as I said, are proteins complexes associated with the centrosome. And right here, as you can see, kinetochores are these protein molecules right here attached to the chromosomes. Right here, these protein molecules are called kinetochore microtubules right here, and these are kinetochore microtubules. On the diagram right here, these are kinetochore microtubules, but the protein molecules right here is called kinetochore. I hope there is a fine line difference, which you should know that kinetochore microtubules attach to kinetochore, and kinetochore attach to chromosomes, and of course these are the ones like a rope pull the chromosomes. Okay. Overlapping. Non-kinetochore microtubules, another terminologies. These are non-protein molecules, kinetochore. Some textbooks says, what is Amir? What is the function of an aster? Some textbooks do not say the definition of aster. We don't know. They are there to help, the centrosome, but really, some people say we don't know. Okay, microtubules, as you can see, chromosomes, centrosomes. This is a nice micrograph picture of whatever you're seeing up there. Is there any question about that? So I defined all of those terminologies for you. Another video. Okay. Here are the chromosomes, and those are centrosomes. Okay. What is cytokinesis? In telophase, genetically identical daughter nuclei form at opposite ends of the cell, cleavage farrow and cell plate. Animal cells have cleavage farrow. Animal cells have cleavage farrow. Plant cells have cell plate. So cleavage farrow is for animal cells, and cell plate is for plant cells. And what is the difference, Amir? Right here. That's the difference. So, are you guys ready? I don't know, are you guys copying this down? I don't know. There is nothing here to copy down. Last slide, yes, you could copy these down. but here you should pay attention. Is that right? So what happens when a cell, imagine the whole thing that I'm drawing for you is a cell. And chromosomes divided, you all know what I'm talking about. They went to the opposite end of the cell. Some out of the 46 chromosome, 23 went on this side, 23 went on this side. I'm going 46 on this side, 46 on this side. I'm sorry, not 23. I'm talking about meiosis. Okay, 46 went on this side, 46 went on this side. And now cytokinesis is when the cell is, you see the cleavage furrow right here? You see the cleavage furrow? The cell, and I cannot break my back for you guys. If I could break my back and then bring it right here. Now you have two cells. This is in case of animal cells. They undergo cleavage furrow. Cleavage furrow. So on your microscope slides, whenever you see cleavage furrow, you should see cleavage furrow. If you don't see it, it's not telophase. It is anaphase. Oh, Amir, the chromosomes, I see chromosome on this side, I see chromosomes on this side, but do you see cleavage furrow? If you don't see cleavage furrow, it is not. Am I making sense? It is not telophase. Now, what happens in plant cells? That was, you see the cleavage furrow, nice, beautiful scanning electron picture. And it goes all around. It's just not at one end. It goes all around. The models we have in the lab, it shows that. Plant cells, it's a different story. They have cell wall. They do not undergo cleavage furrow. What happens after the chromosomes divide, I'm talking about cytokinesis, what happens in the middle of the cells, they start laying down protein molecule, phospholipid, cellulose. Right here, they start laying them down. Just like making a dam. How do you guys think make a dam? They start putting concrete and little by little rocks and stones, gravel, until the dam is coming up. Am I making some sense a little bit? So they start laying down some materials of the cells, and eventually it becomes a solid and form. This is called cell plate. This is called cell plate, the material. And this is a transmission electron picture. Again, on your onion root slide, you should be able to see the cell plate. If you don't see it, it is anaphase. When you see it, it is telophase. Remember, on your mitosis, you have prophase, Alicia, you have prophase, metaphase, anaphase, telophase. There are 4 stages on the microscope. For final lab practical exam, you should be able to identify. Final lab in May. It takes place in May. I'm speaking of May. On the microscope, you should be able to tell what stage of cell cycle. Prophase, well, even interphase. You should be able to tell interphase. Interphase, but it's not stages of mitosis. Mitosis starts from prophase, metaphase, anaphase, telophase. Look at your PowerPoints. I'll be able to identify. Cytokinesis, cartoon. Let's see what the cartoon says.
In animal cells, cytokinesis begins with the formation of a cleavage furrow. At the site of the furrow, a ring of microfilaments contracts, much like the pulling of drawstrings. The cell is pinched in two, creating 2 identical daughter cells. In plant cells, cytokinesis begins when vesicles containing cell wall material collect in the middle of the cell. The vesicles fuse, forming a large sac called the cell plate. The cell plate grows outward until its membrane fuses with the plasma membrane, separating the 2 daughter cells. The cell plate's contents join the parental cell wall. The result is 2 daughter cells, each bounded by its own continuous plasma membrane and cell wall.
That's it. Another one of the cleavage furrow, so on and so forth. Okay, this is what your microscopic slides onion root tip look like? This is a rectangular cell. Let's go over it on the microscope. Don't say me, you didn't say it. It is in your textbook. It is in the PowerPoints that I put on DocuShare for you guys. So next time for the lab, when you come back from spring break, we are going to look at these slides. So you do have a cell, plant cell inside. Can you see those dots? These things? Can you see them? So what stage that is? Prophase. Then again, pro-metaphase. I will not bother you during lab practical exam, but this is a prophase also. But look at the chromosomes. They're all lining up in the middle of the cell. These are chromosomes lining up in the middle of the cell. And what stage that is? Metaphase. And now sister chromatids separated. That's anaphase. And now look at the cell plate. Nice and beautiful. Right here. Of course, the sister chromatids separated. And what stage that is? Telophase. You should be able to tell them apart on the microscope in the plant cell. And of course, he broke them down one by one for you guys. And I didn't delete these slides. I want you to look at it. In bacteria, quickly, let's talk about bacteria a little bit, and then we'll stop right after bacteria, because the other bacteria divide by binary fission. Bacteria do not have mitosis. Prokaryote bacteria and archaea are reproduced by a type of cell division called binary fission. And I'll show you a picture. Hopefully, it makes a little bit more sense. In binary fission, the chromosomes replicate. Yes, they have to replicate, just like eukaryotic cells, beginning at the origin of replication. And two daughter chromosomes actively move apart. The plasma membrane pinches inward, dividing the cell into two. That's it. Very simple. Bacteria division is not as complicated as eukaryotic division. Are you ready? Right here is chromosomes. Chromosomes duplicate, just like they form a bubble, just like the other one. And right here you have the origin, two separate set of chromosomes, look like spaghetti, and then the cell membrane pinches off. We do not use any of those terminologies we used for eukaryotic cells. We do not use cleavage pharaoh here. I do not use it because those terms are reserved for eukaryotic cells. And right here at the end you have two cells. Cell cycle. But you saw how bacteria divide. A few questions. Which one came first? Binary fission came first or mitosis? And why? Open floor for discussion. Based on what you heard from me since the beginning of semester. Steven, don't eat your nails. Tell us what, don't worry about it. It's not that stressful. Would it be bacteria? Why? I agree.
Whenever there's two things, there's archaea, and archaea is ancient bacteria cells or whatever. And so I'm assuming they came forth before mitosis because maybe this is happening.
You cannot hear me, but can you hear
Well, I'm
me?
not sure if
Area?
it's right, though.
That's okay. You,
Okay.
no. If you're wrong, I say no. That's not right. So what? If I say no, what? Will you lose value to it? No. Say no. You can say it. Explain it.
Well, like what I said, so prokaryotic two parts, archaea and what is it?
That's fine. Yes.
Yeah, and
But-
archaea is ancient bacteria and whatever, and I'm assuming they came first before mitosis because mitosis happened in eukaryotic cells.
Right. Mitosis happens in eukaryotic cells. Who came first? Eukaryotic cells or prokaryotic cells? We said that from the beginning of semester. Prokaryotic cells were formed in the bottom of the sea first. 3.5 billion years ago. You went to that physics talk on Friday? When first was the Big Bang, the formation of the galaxies, the universe? When, how many years ago that was? The Big Bang? Did you talk about it? Did you go to the talks?
No.
Who went? The physics, the lady. What? How many?
I like 6.
Huh? Did you go to the Friday talk?
Yeah.
How many years ago was the Big Bang?
Like 13 something billion?
13 point something billion? 13, 14, 15, whatever it was, half billion years ago, before life was on Earth, Big Bang happened. And then after that, we had 3.5 billion years ago, the first bacteria formed. The bacteria evolved to prokaryote, to eukaryote. So binary fission. Do you guys see my mentality? Do you see my reasonings? Binary fission was before mitosis. Mitosis happened during the how to prove that? There is a way to prove it, that there are some eukaryotic cells, protozoa. You all know what a protozoa, protista. There are some eukaryotic cells, the chromosomes, the cell division occur by binary fission. So it just didn't happen overnight. That's how evolution is. It did not happen overnight. The transition was slow. So some nucleated organisms undergo binary fission too, but those are protozoa, protista, that you already looked at, some bacteria, some amoeba and paramecium in here. Okay, so they do undergo binary fission. We do have some eukaryotic cells. Is there any question? I'm going to talk about the control system, how cells are being controlled, and then what happens in cancer cells. In cancer cells, we do not have a control system. They lose their control system, and that's why the cells keep multiplying and multiplying and multiplying. I didn't talk about abnormal conditions. I talked about normal conditions. Yes?
So with G1 interface, what's G2?
Yes, G1, S, and G2, they're all portion of interface. Did I answer your question?
Yeah.
They're all three of them. Interface is broken down to 3 stages. G1, S, and G2. And what happens during G1 and G2, the material like a Golgi apparatus, mitochondria, they start dividing. They become 2 of each. Am I making some sense? Other organelles, other protein enzymes, they all multiply during G1, G2. The cell starts growing because each cell at the end needs enzymes, mitochondria, chloroplast, lysosome, whatever have you, they all have to multiply. Do that make sense? And then chromosomes, nucleus has to divide, which is the M phase. I hope I'm making some sense. Do that make sense? If I don't make sense, please read your stuff. I feel bad. I feel very, very bad. For all my classes, even the online classes, Maya, I give sermons, except you guys. Well, you guys, I give it in a different ways. But let's look at beautiful words to live by. Did we go over this one? Beautiful words to live by?
Maybe.
Best email ever. You've seen that one? No? Earth and other planets? See, I feel bad. You have not? Have you seen this one? Ah, where have you guys been?
Lost.
Beautiful words to live by. Anger. Did I go over this? Yes?
Yeah, I remember that one.
Best email ever. Let's go over this one. Have you seen this one?